Hello guys, welcome back on this journey of ours through mathematical topics. Our first video, part A, was differentiation. So now we are on to part B of differentiation. Part A was about the basics of differentiation, how we try to simplify differentiation, and if you can remember, the most important things are mastering your indices. Then you have to know that it entails multiplication and subtraction. Now we're going to part B, which involves much more complicated questions in differentiation, and we'll explain to you why differentiation came about and the use of differentiation. So to begin, let's say someone is walking along a straight line. At any time you meet that person, his direction is the same. Now if someone is walking in a curve-like manner, at any time you meet him, his direction is different. Now differentiation is an easy way, is an expression of a curve which permits us to know the direction at any given time. There are curves which are is a y-axis, x-axis. There are curves which are straight lines, which are not complicated, and there are curves which are like this. So now a gradient is a way of expressing the rate of change of direction for the curve. Now curves are expressed in functions of y and x. So let's say f of x equals to x squared. It implies y equals to x squared. So this is an expression of a curve. Now the gradient of this will be the differential of this, and we'll get dy on dx from our understanding to be 2x. So this is now the derivative, and this is the gradient function. So this function permits us to get the gradient at any given point. So now let's take the first example. Let's say the equation of a curve is given as y equals to 6 minus 3x minus 4x squared minus x cubed. This is the equation of our curve. Now we should find the gradient at the points -2 and 4. This is the x value and this is the y value. Now we have our y to be 6 minus 3x minus 4x squared minus x cubed. Our derivative function now, which is dy on dx, will be minus 3 minus 8x minus 3x squared at points -2 and 4. We replace the x values with this. So we have -3 minus 8 times -2 minus 3 times -2. And solving this gives us -3 minus 8 minus 16. It gives us 1. So our gradient is 1 at the point -2, 4 for this equation, for this curve. Now there's a question here. This is how GCE type question comes. Find the coordinates on the curve y equals to 2x cubed minus 3x squared minus 8x plus 7, where the gradient is 4. So we have to look for the points, the coordinates at which the gradient is 4. Now, first thing we do is we understand we have to differentiate this in order to get the gradient. So we write our y equals to 2x cubed minus 3x squared minus 8x plus 7. Now dy on dx will give us 6x squared minus 6x minus 8. And we have dy on dx to be 4 based on this statement. So it implies 6x squared minus 6x minus 8 equals to 4. It implies 6x squared minus 6x, we bring 4 all over, so minus 8 minus 4, that will be 0. So it's 6x squared minus 6x minus 12 equals to 0. And now we have to factorize this. So factorizing this, if we take 6 out, we have 6x squared minus x minus 2 equals to 0. So still maintaining 6 out of the bracket. Factorize this, you look for 2 values. This will give us x minus 2 and x plus 1. All this equals to 0. Since this is equal to 0, it means we can get rid of this because 6 multiplied by this. So it implies x minus 2, x plus 1 equals to 0. So it means this product gives 0. So it means any of these has to be 0. So let's consider this. If x minus 2 equals to 0, it implies x equals to 2. And if x plus 1 equals to 0, it implies x equals to negative 1. So we have 2 points in which this our gradient can be 4. The first point is when x equals to 2. Now when x equals to 2, what is the value of y? When x equals to 2, we come back here and replace wherever this function, wherever we find x, we replace it with 2 and we get y. We do the same for this. We have our equation is y equals to 2x cubed minus 3x squared minus 8x plus 7. So taking x to be 2, our y value will be 2 cubed minus 3, 2 squared minus 8 times 2 plus 7. That will give us negative 5. Taking x to be negative 1, this will find the value of y. Y is going to be 2 negative 1 cubed minus 3 negative 1 squared minus 8 into negative 1 plus 7. And this will give us y equals to 10. So our 2 points are when x is 2, y is negative 5. And when x is negative 1, y is 10. So on the graph at these 2 points, our gradient is 4. And the last question we have is determine where, if anywhere, the function f of x equals to x cubed plus 9x squared minus 48x plus 2 is not changing. Remember we said a gradient is a measure of how the direction changes. So if they say there is a point at which the curve doesn't change, means there's a point at which the gradient is 0. So now we have to look at those points at which the gradient is 0. Look for those points. And the best way, easiest way to get the gradient, we have to first of all differentiate. So f prime of x will be 3x squared plus 18x minus 48. This is our derivative. Now, from our question, it says the gradient doesn't change. So it implies f prime of x equals to 0, which implies 3x squared plus 18x minus 48 equals to 0. Common, what is common here? 3, yes, because 3 will go here one time, so that will be x squared plus 6x here minus 16 equals to 0. So it implies this product should give 0. So x squared plus 6x minus 16 equals to 0. Now we have to factorize. We have x plus 8, x minus 2 equals to 0. So let's take the first. If this gives 0, it implies x equals to negative 8. And if this gives 0, it implies x equals to 2. So we have x equals to negative 8, x equals to 2. And now to find the values of y, we go back and substitute x in their original function. So let's take f of x equals to x cubed plus 9x squared minus 48x plus 2. So substituting x to be minus 8, we have minus 8 cubed plus 9 minus 8 squared minus 48 minus 8 plus 2. And then we open and we do the same for x equals to 2. We substitute into this and we'll now get our values for y at which the gradient is 0. So we've come to the end of this video and we hope our examples are explicit enough. So if you have any differentiation question which you've come across which is giving you a headache, you can send it to us, write on the comments, and we'll get back to you as soon as possible. Thank you very much.